This is lesson 3.6 from the Introduction to Algebra book. Lesson 3.6 in my classroom is on page 79. Just one page of notes, very short notes on this lesson. All right, lesson 3.6 is titled Mixed One-Step Equations. Mixed one-step equations. And here's your warm-up. The warm-up takes up most of this page, but that's okay because as it turns out, the notes are very short and concise, so we'll still only use one page for notes today. All right, so the instructions for your warm-up are: write and solve an equation for each sentence. Write and solve an equation for each sentence. All right? And the first one is the sum of 14 and y is 32. All right, there's the first one. Gonna need some lines to make that happen, so I'll put 3 in between, I think. All right, number 2. The product of 3 and x is 12. The product of 3 and x is 12. All right, and the third and final warm-up sentence. 1, 2, 3. Number 3. The number G decreased by 100 is 10. All right, there's your 3 warm-up problems. Skip 3 more lines here. 1, 2, 3, and we've got our I can statement. I can. This is what we will do during this lesson. I can solve a variety of one-step equations. Okay, one of the reasons our notes are so short for this lesson is it's all stuff you already know. In previous lessons, you learned how to do, you learned how to solve equations where you were required to use the inverse operations for addition and subtraction. And then you had a lesson where you learned how to solve equations where you solved by using the inverse operations for multiplication and division. Well, now in this one, they're mixing all those kind of problems together. So you'll have some that you'll add, you'll have some that you'll subtract, others you'll multiply, and others you'll divide to solve the equation. They're just mixing them all together. So it's all things you've learned how to do before. all things you know how to do. Just getting extra practice. Really, the point winds up being, if I mix them all together, can you recognize which inverse operations you need to apply in order to solve the particular equation? Okay, so what I will be doing for our notes is just giving an example of each of the 4 different types, and that's it. That's all we'll do for notes on this one. Okay, all right, so the instructions for these problems are: solve each equation, check solution. Okay, the usual instructions for these kinds of equations. All right, let's see. 1, 2, 3, 5, 6. Yep, we're good. All right, so problem number 1 is b over 8 equals 3 8/10. All right. Okay, so I know my first step. I'm gonna build my fence here, as I like to say. All right, and my first step is I need to figure out what inverse operation I have to apply to get b by itself. B wants to be on its side of the equation in his little house all by himself. All right, so I have to get rid of the 8. Well, I know this fraction bar means division. So the inverse operation of division is multiplication. So I'm going to multiply by 8. All right, and that then allows me to cancel out the 8's, bring down the variable of b, and now b is all by itself on its side of the equation, right? Okay, but what we do to one side, we also have to do to the other. So I have to multiply this side by 8 as well. And I'm going to put it in parentheses rather than putting a dot here, just because this is a decimal number, and it can get confusing looking when you have a dot here and a dot there. If you don't put them low enough or high enough, you can mistake the decimals for multiplication symbols. So I'll put that in parentheses instead. All right, so 3 8/10 times 8 is 30 4/10. All right, so there's my answer. Let's get this up higher. There we go. There's my answer, and now I need to do my check. So to do a check, I simply plug in what I believe I've got for my variable now, where the variable was in the original equation. All right, so I think 30, whoops, I need 30, not 3. Let's try that again. All right, 30 4/10 divided by 8 equals 3 8/10. And I know that 8 does go into 30 4/10. 3 8/10 times. So 3 8/10 does equal 3 8/10. Check. I've got that one correct. All right. Done. Okay, so there's the first one. Now here's the second one. Number 2 is 10 plus y equals 44. All right, gotta build my fence. First step, y wants to be all by itself in its little house over here, so we've got to get rid of 10. Got to get them out of there. Even though I don't see an addition sign in front of 10, if there isn't a minus sign in front of it, then I know it's a positive number. So 10 minus 10 is what gets me 0. And that's what I want so that I can zero it out, right? So that gets y all by itself, exactly where it wants to be. Happy to be alone. Y likes to be alone. All right, so, but what we do to one side, we have to do to the other. So now we have to subtract 10 from this side as well. So 44 minus 10 is 34. Y equals 34. All right? But I need to check and make sure, check my answer. So I'm going to plug in 34 where I see y in the original equation. So 10 plus 34 equals 44. All right, so 4 plus 0 is 4. 3 plus 1 is 4 equals 44. Check, that is true. So we had the right answer there. All checked out. Okay, all right, so next one. Number 3. Boy, I better start scrunching these together a little tighter. I'm going to run out of room. All right, p minus 7 and 2/10 equals 13. All right, build my fence. First step, I've got to get p all by itself. I see subtraction here, so that means I have to add 7 and 2/10 to make it 0. And then that gives me my variable isolated on one side. P is all by itself, just like it wants to be. But what I do to one side, I have to do to the other. So I have to add 7 and 2/10. So if you need to, remember we got to line up those decimals. So you can kind of fill that in there if that helps you. All right, so 2 plus 0 is 2. Keep the decimal lined up. 7 plus 3 is 10. And 2. So we've got 20 and 2/10. And now I'm having to kind of squeeze these a little tighter together. I don't know if I'm going to have room for number 4 over there. I spaced these out more than I did in my practice notes. All right, we'll make it work. All right, so P equals 20 and 2/10. I think, but now we prove. So we plug this in where we had P. 20 and 2/10 minus 7 and 2/10 equals 13. All right, so 2 minus 2 is 0. Keep the decimals lined up. 20 minus 7 is 13. Okay, equals 13. Okay, does 13.0, 13 and 0/10 equal 13? Yes, we don't have to show this decimal and 0 there, but it doesn't change the value. So yes, it's true. Okay, check. Now we're going to have to squeeze in our 4th and final example really tight over here. See how we can do that. All right, I'll number it up here. Number 4 is 4W equals 80. All right, build my fence. I know that 4W means 4 times W. So to my inverse operation then is going to be division. So I will divide by 4. Should have shown that with some color, huh? Divide by 4. All right, then that gets 4 out of there. And I've got W all by itself on this side. But what I do to one side, I have to do to the other. So I have to divide by 4 over here as well. 80 divided by 4 is 20. All right, but I got to check it. So I'm going to circle my answer here and then do the check below. Boy, we're just barely making this fit. All right, 4 times 20 equals 80. Okay, 2 times 4 is 8. I got that 0, so I know I've got 80 equals 80. Yes, it checks. We have the right answer. All right. So that's your notes for lesson 3.6. Let me get them all into frame there. I know they're a little squished up at the end there, but I think you can see it all okay. Your notes for 3.6. All right, so let's look at some practice problems and get a little bit of practice in on this. Okay, so 3.6 practice problems. We have 4 problems. Instructions for all 4 of them are solve each equation and check your solution. So just like in the notes, I have one example of each of the 4 different inverse operations that you would need to apply. So there's problem number 1, 2. Can I get all 4 of them in there? I think I can, just about. All right. So, problem number 1, x plus 7 equals 32. Problem number 2, y divided by 4 equals 13. Problem number 3, b minus 10 equals 25. And problem number 4, 8p equals 20. Remember, the instructions said to solve each equation and check your solution. So, you may pause the video here and work these out. Okay, so let's see how we solve these problems. Number 1, I've got x plus 7 equals 32. I've got, I'm going to build my fence here. X wants to be in his house all alone. So that means we have to get rid of 7. Well, I see addition here, so the inverse operation is subtraction. So I subtract 7. Boy, I made a weird 7 there. Okay, subtract 7, and now that is has been turned into 0, which means we evicted 7 out of X's house, and that makes X very happy. But what we do to one side, we must do to the other. So we got to subtract 7 from this one as well. I have to borrow. That makes that 2. 12 minus 7 is 5. And 2 minus nothing is 2. Right? So x equals 25. Well, I have to check my answer. So over to the right, I'm going to plug in 25 where I had x. So 25 plus 7 equals 32. Oops. Need a 3 before the 2. Equals 32. All right? Okay, so 7 plus 5 is 12. So I'll carry the 1 and put down the 2. Right? 2 plus 1 is 3. That's 32. So it looks like 32 equals 32. Check. We did that correctly. All right? Okay. Problem number 2. Problem number 2 is y divided by 4 equals 13. So first I build my fence. Y wants to be in his house by himself. Somehow we got to get 4 out of there. Well, this division symbol here, this fraction symbol there means division. So the inverse operation of division is multiplication. So we are going to multiply by 4, and that cancels them out. Now y is by itself. But what we do to one side, we have to do to the other. So now we're going to multiply the 13 by 4. So 3 times 4 is 12. Carry the 1. Okay. And 1 4 plus 1 is 5. So y equals 52. All right? So y equals 52. Let's get that checked over here. So we've got... so we need to plug in 52 where we see y. So over here, we've got 52 divided by 4 equals 13. Okay. Well, does it? I'm not sure. So if I'm not sure, then I'd better set it up and prove it. So 4 divided into 52. 4 goes into 5 one time. 1 4. Subtract and we get 1. Bring down the 2. 4 goes into 12 3 times. Yes, 4 does go into 52 13 times. So we've got 13 equals 13. Check. All right, so yes, y does equal 52 in the equation y divided by 4 equals 13. Okay, number 3. Okay, so we've got b minus 10 equals 25. Let's build our fence and help out b. We've got 10 hanging out in his house, and he doesn't want him there anymore. I see that there's a subtraction symbol here, so I know the inverse of subtraction is addition. So to get rid of 10, I have to add 10. That turns it into 0, and it's gone. So now I can bring down my variable b. It's all by itself on its side of the equation, just like it wants to be. If I added 10 here, then I have to do the same over here. So I add 10 here. 25 plus 10 is 35. So that's my answer. I think, but I have to check it. So I'll take what I think is b, 35, and plug it into the original equation in the position of b. So 35 minus 10 equals 25. Okay, equals 25. 35 minus 10, if I take 10 away from 35, I know I've got 25. So that does check out. B does equal 35. Okay, and the last problem. So we've got 8p equals 20. All right. Well, I know that 8p means 8 multiplied by p. So the opposite of multiplication is division. So I'm going to divide this by 8. And that turns that into 1. And so now I have 1p. But I don't have to show the 1 in front of a variable. So p is all by itself, just like it wants to be. But what I do to one side, I have to do to the other. And how many times does 8 go into 20? It goes into 22 and 5/10 times. All right? 2.5. But I need to check. So I've got 8 multiplied by 2 and 5/10, because that's the variable that we're plugging in. That's what we're plugging it in for, equals 20. Okay? And I know that 8 times 2 and 5/10 is 20, equals 20. So check. And you may need to do some longhand scratching out to the side like that if you're not sure. Double check those kind of things. Okay? All right, so that's your practice problems. We're all done with those. So let's take a peek at your worksheet for this lesson. So the 3.6 worksheet. All of these problems, like I had said earlier, they're mixed operations, but you've got an example of each type. So just pay attention to the operations that are in the equations so that you know you're using the inverse one, the opposite one, to solve for the variable. And please notice too, in the instructions it says check your solution. All right. Now, down here in these 4 problems, you have to figure out first what the equation is. Please notice that where you see the word is, okay, that's your clue for there's the equal sign and what's on the other side of the equal sign. And sometimes it helps students to start there first. Put down your equal sign and what's on the right of the equal sign, and then kind of work backwards to figure out what's the expression on the other side of the equal sign. It says for you to write the equation and solve it. It doesn't say that you have to check your solution. But of course, that's always a good idea if you want to make sure you didn't make any mistakes. All right? And then the final one is a word problem. Again, when you're working this word problem, it helps to try and figure out what is the equal sign and to the right of the equal sign first. Then kind of work backwards to figure out what's your expression going to look like on the left side of the equal sign. Okay? So that's your worksheet for lesson 3.6. That brings us to the exit ticket. Your exit ticket is for extra practice, or your teacher might use it for some type of assessment. So I don't tell you how to do these or give you the answers, but you can pause here and work these out. All right, so that's lesson 3.6 out of the Introduction to Algebra book. Remember, the only way to learn math is to do math, and mistakes are proof that you're learning.